Fantastic. All right, thanks everyone for coming today to the July meeting of the FedRAMP 20X Community Working Group. FedRAMP standard disclaimers apply today. That means all information discussed today about FedRAMP updates, priorities, and policies are for the convenience of the public and are subject to change. Importantly for today, all mention of specific commercial products or services is also for the convenience of the public and does not constitute endorsement, recommendation, or favoring by the General Services Administration. We are super happy here to have two different companies present a demo of some of the work that they've been doing on FedRAMP 20X and that automated validation and assessment journey that they've been on. Before we get into that, we are going to do a couple of quick updates. So last week, you may have noticed, FedRAMP released RFC 12, which was a draft continuous vulnerability management standard. That standard will apply immediately to FedRAMP 20X once it is finalized, although I certainly expect there will be some changes after the public comment period. Once it applies to FedRAMP 20X, we will do the same process we've been doing for everything else, where we'll be doing closed beta tests with Rev 5 authorized providers to retrofit that slowly, carefully, and deliberately to Rev 5. Also, big news today, the Phase 1 pilot page for 20X has been updated to show that we now officially intend to stop accepting pilot submissions on August 19th next month. Now, that is not the end of 20X. The goal very much is that at that point in time, we will focus for as much time as needed on finishing the reviews and assessments of the current pilot participants. Then we'll use that to pivot into a slightly more clean and updated standard that makes more sense for everyone else. And then we will proceed to offer for a extended period of time, limited pilot authorizations that will just be open to the public until eventually at some point in the future, this becomes a formal, never-ending path to authorization. As of today, we have received 12 20X low pilot submissions, and we expect the first cohort to receive formal limited pilot authorization as early as next week. So stay tuned for that announcement. Maybe the week after, we'll see. All right, so today we've got two of those pilot participants here to show you a bit more about their approach to 20X. Big thanks to Knox Systems, Coalfire, Meridian Knowledge Solutions, and Fortreum for agreeing to show you all of this today. I want today to be about them. So as we do Q&A and after each presentation, as well as Q&A together at the end, we'd like those questions to be directed at our participants today rather than at FedRAMP. And we'll get to see how you can all learn some cool stuff together. Instead of long intros, we're going to jump in with some initial Q&A here to set the stage and then do demos. If you want to read more about our participants, there's a link in the chat. All right, so I'm going to start off with a question, kick it over to Knox to begin with, which is, why did you decide to participate in the 20X Phase 1 pilot?
Yeah, so Pete, howdy everybody, Chris Johnson, CTO for Knox. And just a really quick kind of overview of who we are. Knox is the largest and longest running federal managed cloud across FedMod to IL4, and pretty soon we'll be in Fed High. And we've been running Adobe's federal environment for a little about 10 years. And to do that at scale, we built an AI auditor called Knox AI. And we've been using it in production with our agencies. So we've been doing literal continuous assessment using Knox AI. Agencies that participate in our collaborative Kanban process see real value in this level of transparency, and they gain an understanding of our security posture, thus making the conversation more productive. So to bring this full circle, when FedRAMP 20X first started, we were very excited because we were fully aligned with the mission of 50 plus authorizations a week. We wanted to showcase what real continuous monitoring looks like in production. And really, it's not theoretical. We're already doing it. And though, no better way to contribute than the FedRAMP 20X successfulness to show, not tell, how it works.
That is awesome. Thank you so much. Adam, how about you? Why did you guys participate in the pilot?
Thanks, Pete. Our story is actually like very grassroots, right? Our participation in the pilot is solely based on like, we're just a cloud service provider. We were gonna do a Rev 5 technically, pursuit. And, I've been in Meridian for 7 months, so I kind of came in like agent zero to come in and like, let's get authorized. And I was halfway through drafting an SSP in the Rev 5 standard and doing all the documentation and diagrams. And then the pilot came out and it was like, I told my boss, like, hey, I think we can do, and by we, I think it was just me. So it's like, I think I can do it. And, so this is a story, like our story is really just like, we're just a little guy and we wanted to be in the cool club of FedRAMP. We have federal customers. We've been in a federal space for decades, but FedRAMP specifically was a business goal of theirs. And once I got here, I saw the pilot as an opportunity to just do it that way. It was never like, I'm going to change the world. It was just like, I want to do this. And then it slowly got out of hand, but in a good way. So.
Love it. Also love the idea of FedRAMP as a cool club. I think that's right. That's what we need to create together. Adam, just for your awareness, your audio is breaking up a little bit. We could hear you, but it was a little bit difficult. You might want to check, make sure that you're using a microphone in your earbuds rather than like your laptop mic or something like that. Otherwise, we could hear you, so it's all good. All right, I'm going to skip the other questions because, as usual, I rambled longer than expected at the beginning of this meeting, and I'm going to go ahead and hand it over to CJ to give us a demo. And as CJ is going through this demo, and the other folks from Wiz and Coalfire are participating, if you have questions about what you see, or you just have questions you want to ask at the end, go ahead and put those in the Q&A in the chat. We're not going to interrupt the demo to ask them, but we will ask them at the end. All right, over to you.
All right, and Irina, I'm going to kick it to you.
Awesome. So I'll do a tee up of what we did here at Knox, and then you'll hear much more from CJ and from our partners Wiz and our 3PAL Coalfire momentarily. So first of all, Pete and the entire FedRAMP team, thank you so much for having us here today. We're really excited, we love the name, demos, not memos. We're so thrilled to be here. So again, we're just going to very quickly tee this up. This is not going to be a PowerPoint situation. This is a demo, but we want you to have context of what you're looking at. So very quickly, joining CJ today is myself. I'm the CEO of Knox. CJ is obviously the CTO. John, JP from Coalfire, Managing Principal of Cloud Audit, and Will, who oversees SLED Solutions Engineering at Wiz. So thank you all for being here as well. So again, as CJ mentioned, Knox runs the largest and longest running FedRAMP cloud, and we've run Adobe's federal environment for over a decade. We have 15 ATOs across DoD and civilian. And the way we do all of this and run all of these environments, as CJ mentioned, is we built this tool called Knox AI. And the reason I'm going to tell you a little bit about it is because this was really the crux of what we submitted as part of our pilot. So what it is, in a nutshell, in plain English, is Knox AI is our AI FedRAMP auditor. It's trained on our 10 years of real world FedRAMP audit data. So, I mean, CJ literally built this boundary, started in 2011 and has been authorized for, well over 10 years. Through all of the revisions. There's a lot of SSPs here and so on. And today we use Knox AI with our agencies, including multiple agencies in the DoD, the DHS, Treasury, and more. Some key things to know about it from a tech perspective. The first is it's an autonomous pull-based scanning architecture, right? So this is an agent that scans at the infrastructure's code layer and cloud config every 6 hours, flags issues, suggests fixes, and there's no manual evidence push that we're doing. It is just pulling. It's end-to-end coverage, so it's not sampling. It's 100% of cloud resources are being scanned. And we integrate, we don't do this alone, we integrate with important tools. The most important is Wiz for issues and vulnerabilities, right? That gives us the full picture of the environment. And then furthermore, we plug into GRCs and trust centers. In our case, we use Strata for the non-code controls, the policies, et cetera. And then all of that gets boiled down into, and this is really originally why we did this, is to manage POAMs. This is the tool by which we not just audit the entire boundary, but this is how we manage POAMs. This is how we run Conmon, as CJ just mentioned. And so for our submission, I think everyone knows what a FedRAMP 20X pilot was set out to do: accelerate and simplify Fed low authorization for modern cloud vendors through automation, reuse of existing audits, machine readable evidence, cutting time and cost authorization. We know this. And just some of the key things that we really anchored on that were part of that initial, go from Pete and team. Use existing audits, submit in code, automate security, obviously partner with your 3PAL, and obviously be a cloud native, meet the eligibility. So what we did was we teamed up, of course, with Adobe, because they are certainly one of the largest applications that are in our environment. There's multiple Adobe applications in there. Of course, Wiz, because it's a core part of how we understand the security of our very, very large cloud. And of course, our 3PAL. We've been working with John and team for well over 10 years. And of course, it was a perfect place to team up. And so what we did was adapted Knox AI for FedRAMP 20X. Specifically, we made 3 additions. The first is obviously the KSI framework. So we incorporated the 9 KSIs derived from NIST 853 into the Knox AI knowledge base to drive real-time control evaluation. If you think about what Knox AI is, there is a knowledge base, and CJ will talk about the architecture in just a second, but basically it includes all of the Terraform code on the internet. So it's something like 70,000 plus files, if you will. Obviously, they're not kind of stored in files of all Terraform code on the internet. It includes NIST 853 controls, and it includes all of our proprietary 10 years of audit data. For FedRAMP 20X, we also layered in the KSIs. So just kind of how to conceptualize it. We also then on the back end, so that was kind of at the ingestion and knowledge base point. On the back end, we added in the machine readable and human readable outputs. Today, we use Knox AI as a self-contained system, and then we download things and put them into Excels. And on the DISA side, we upload those Excels with poems into EMAS and the regular process that all of us know and love. In this case, we created those machine readable and human readable outputs as JSON outputs. You'll see examples of those in the entire schema. That's also available on our GitHub. And then, of course, JP and the Coalfire team validated that. And so just to give you a visual, again, kind of step by step, we started with Adobe Connect, which not for nothing is already a FedRAMP moderate Rev 5 authorized application, right? So we kind of have a little bit of a ground truth on it, if you will. We scanned it with Knox AI with those FedRAMP 20X updates. We received the JSON output, right? All of the findings, we then ported over into this JSON output. Again, this is available via REST API or in the Trust Center export. And then JP and team from the Coalfire side assessed and provided the attestation letter. And so I'm going to hand it over to CJ for just a quick description of the under the hood, how does Knox AI work? And then we'll actually show it to you.
Yep. So the important thing to know here is Knox AI is contextually based. There's not one single source of truth or evidence that's out there that really gives you the full understanding of what KSIs are. For example, if you look at your hyperscaler, the metadata that exists within it is probably about 85% of it, but it's not all the way there all by itself, even if you utilize 100% of cloud native services. With that said, those ingestion points that we have is not just what's existing today as state inside of your hyperscaler. It's the prequel to that, the infrastructure as code, all the supporting documents that gives that additional context on what process or procedure may be, should it not be directly accessible inside the hyperscaler, as well as integrations with CNAP. We use Wiz. And because we have these 4 different ingestion points, what we're able to do is essentially have an agent coordinator that spins up 2 agents, an assessment agent and an infrastructure agent that has accessibility into our proprietary databases, right? Whether that be a vector database that's aligned specifically with some meta indices that gives a high level of specificity towards what we're scanning, or whether that be to just some general knowledge that we've placed in as it relates to supporting documentation. After those scans are completed, what we do is we ship those results off to a set of quality assurance agents. Those QA agents operate at a high scale, and they do a collaborative scan where there is a conversation that's initiated, where they essentially sit down and collaborate and realize if there are false positives or not. And they do this based off of their understandings and the findings it is that they've had, plus what it is that they've reviewed from the assessment agent as well as the infrastructure agent. Once that's completed, another sub-process kicks in, and then out pops the machine readable JSON, which is also manifested in the Knox UI, the Knox AI UI, that is. Yep, Irina.
Yeah, perfect. Okay, so enough preamble. Let's actually show it to you. So, and we'll obviously keep all of these I think these slides will probably be made available. If not, we can certainly make them available. So here I am. I'm in Knox AI as a user. Now, I want to preface this by saying I am obviously not going to show you our actual submission data because that is Adobe Connect assessment data. So we've sanitized that data. That's why I'm running demo mode, but it will have, everything, just not the actual, all of that is behind Trust Center and only accessible to FedRAMP and our agencies. So long story short, first you start off with obviously boundaries. So, in our case, because we're a managed cloud, we could have, as many boundaries as we have customers and how many customers our customers have, right? Some of our customers deploy single tenant and so they have, 10 agencies as customers, and that ends up being multiple boundaries. The important thing to understand is it is a single tenant deployment for every single customer. And so it allows us to really logically segregate everyone, reduce the blast radius, et cetera. But coming to the FedRAMP 20X piece. So the first thing to understand is this is continuous, right? So these scans run multiple times a day. Every time we detect new CVEs coming out from Wiz for any open source libraries that any one boundary and any one application in our boundary is leveraging, or any new code is pushed, a new scan kicks off, it is continuous. And so typically what we do, just to kind of, again, give you a baseline, typically what happens is we have findings, right? And they're, high, medium, and low findings. And they're very much based on the NIST 853 controls. So here we go, SC28, S3 buckets should be encrypted at rest. We are, again, scanning at the infrastructure as code layer. So we know exactly which resource is affected. And of course, we can provide the remediation steps, both at the CLI command and the Terraform. And then we take it, or, in this case, or our customers take it, Adobe, et cetera, and they make those changes in their repos, and they repush that and so on. And that's really, again, what allows us to really run this cloud accordingly. And of course, run POAMs off of it. So every finding is then immediately reviewed and then POAM'd in 99.9% of cases. And so again, as I mentioned, we run our POAMs through this process. And so, because this is a demo, we thought it'd be fun to assign all the POAMs to Pete. So you have a lot of work to do, sir. But the point is, this is all, again, auto-generated from all of the findings. So that's the NIST 853. This is how we use this for FedMod. This is how we use this for DisIL4, et cetera. And these POAMs ping out to dev teams and Slack and Teams and PagerDuty and whatever tool they want to use. Layering in the KSIs, again, it's the same process. It's just referencing this new framework, if you will, called KSIs. And so what you'll see immediately is obviously that, we're scanning against the 9 KSIs, and then we have findings against them, right? And so in this case, it's not surprising, I know it seems funny that, oh, wow, you have a score of 100 down the line. It's not totally surprising because, again, we assessed a FedMod application that is very tightly managed. We run Conmon twice a week. We have done so for the last 10 years. We run a very tight ship here. And so it's not totally surprising that honestly, I'm glad we passed everything. I'd be very concerned if we didn't. But I think what's the most important thing here to demonstrate for you all is, again, it's taking that same format of what's the KSI, what's the evidence that's being used. If it passed, what's the reason? If it failed, what's the reason? So very much like you see in LLMs giving you sources, we are giving you sources, right? So here's the evidence, 2 policies, 1 appendice. Here's the exact documentation that was referenced to come to this conclusion. And here's the metadata for it as well. So again, it's important to understand that you can ground truth back to exactly what you are assessing against, and then interrogate it, right? The very important thing to be able to do is to risk adjust, as we all know, and you can do that right from in here because you can look at exactly what it is that was what was found. So in this case, we're talking about monitoring supply chain risks. Okay, why did it pass? Well, we can see a WAF. Adobe Connect is a virtual conferencing tool for those of you who don't know. So we use a lot of WAFs because we have a lot of ports open for video conferencing. Obviously, it's based on WebRTC, and obviously procedures and frameworks. So again, both policy and code all living in one place. And then the last thing I'll just share is from a, we talked a lot about Wiz, right? And so we call it SAST, recently technically, we agree that should technically say SCA. But the point is, you need to do static code analysis. You need to understand your CVEs, and it's really important to understand how we do that, which is we're leveraging Wiz issues. And so all of those are being brought in here. Wiz issues, if you're not familiar, does a phenomenal job at bringing into the into one pane of glass, what are all the CVEs, prioritized by what's actually exploitable, and also has a fix. So, not to get into the request for comment whole topic that's currently going on right now, obviously very related to that, but we find Wiz issues Wiz has done a phenomenal job of structuring the overwhelming amount of CVEs that all of us deal with on a daily basis, and actually allowing us to remediate those that actually matter, right? And so very similar framework here. Obviously, what's the vulnerability, what's the remediation, and what's the fixed code, and obviously any change history. So just to wrap us up, bring us home here. So the outputs, again, obviously for FedRAMP 20X specifically, Knox AI is something that obviously we use, but as requested by FedRAMP, we have this all in JSON outputs. This is just a screenshot of the schema. If you want to see our GitHub, you could probably find it just on Google. We added a QR code in here just for you to see it. It's also right here. This is our submission. So everything we're talking through today is there. And really, again, the key thing is, the JSON, obviously machine readable evidence. We'll hand the mic over to JP in just a second, but obviously validated by Coalfire. Really, the thing I can't stress enough is, obviously it took months and months to build Knox AI way back when, but this was, well before FedRAMP 20X started. But the key is that, this entire process, we had to bring in the KSIs, of course, and create the JSON output, but end to end, it took less than 90 minutes, right? And that's kind of the wow factor here. So just again, last thing I'll leave you all with is, why we believe AI audits are the future of FedRAMP. Obviously, there's human in the loop. There's 3 PALs involved continuously. But really where we see this is, number one, scale, right? There's thousands of resources that are evaluated across multiple accounts in minutes, which leads me right into the next point, which is speed. It reduces that authorization time from months to hours. And the other piece that is really important is consistency. So AI-driven evaluation removes human variance. I think we've all been in months-long audits, or think about your auditor over multiple years. If your auditor has switched out the audit, if your auditing company, 3PAL, have switched out the actual team that audits you, you as a CSP know how, frankly, frustrating that is, because you now have a whole different set of humans that are evaluating. We've been very fortunate with Coalfire that we've worked with the same team for 10 years straight. But the point is, human variance is very real in FedRAMP audits today because they're manual and because they're human audits. So bringing in a much more standardized, programmatic, let computers do what they're really good at doing, being consistent, way to do it is, we think is the obvious thing to do. And frankly, what the commercial industry has been doing for years. And of course, it's flexible, right? So we were able to literally add in KSIs within a matter of days. Now, obviously, CJ didn't really sleep a whole lot that week that he was adding in the KSIs into the whole Knox AI knowledge base. But the point is, it wasn't months and months of development time. It was a fairly short sprint, all things considered. Obviously, reduces manual effort by, you can't, it's not zero, but 99.9%. And it's trustworthy because you have this pull-based model with verifiable audit trails. You can drill down to the resource. This isn't a black box. And I guess probably the most important thing is we're already doing this in production, right? So Knox AI is live in production with DoD, DHS, Treasury, and 10 plus more agencies. And again, we're not here saying, hey, everyone should use Knox AI. That's not at all what we're saying. We don't even kind of support it for anyone externally. It's just for us. But what we really hope to impart here and by submitting with FedRAMP 20X is that, you know, everything that Pete and team are trying to do, we not only agree with, we're doing it. We hopefully we're showing you kind of how successful it can be for you, for your agencies, for your 3PAL, for everyone involved. And ultimately, we hope that this drives more cutting edge software being accessible to our federal, to our military, and everyone serving our government. So with that, let me hand it over very quick for a few remarks from JP and from Will from Wiz, and open it up to questions.
Hello, everyone. My name's JP from Coalfire. I know we're running short on time. Irina and Chris have been, and CJ have been awesome partners in this entire endeavor, working with us, making sure we've kind of took a trust but verify approach where we actually looked at the KSIs. Plus, we also looked at the mappings to the individual NIST controls to make sure there was nothing missing or nothing that could potentially add benefit by adding or removing. You know, obviously this is supposed to be a streamlined process. So we looked at the KSIs, the mapping to NIST 853. Then we actually went in and looked at the JSON file and yet again took the trust but verify approach, and we were looking for false positives, false negatives, inappropriate evidence or things like that. And so we were actually looking at the evidence. We were looking at the whole picture. And really, at the end of the day, our idea is, from Coalfire's perspective, is, you know, you validate the schema, the mappings, you do all that extra effort to make sure that the tool is doing in fact what it is, and now you can actually have a level of trust, assuming it doesn't go through a major revision or something like that. So we actually wanted to make sure that everything was in place, all the information presented is accurate. And then, as Irina stated on one of these slides, it literally took an hour to put together the attestation letter, and I left it pretty generic just because we do have to have that trust with the PMO, and we do need to make sure that we are in fact meeting Pete's goals and things like that. So like I said, I know we're short on time. I'll turn it over to Wiz, I guess.
Thanks, JP. Yeah, so from the Wiz perspective, really our key in this is, like Irina and CJ talked about, is feeding as much information as quickly as possible, constantly assessing, constantly reviewing, constantly, you know, as things change, getting that information as quickly as possible into that Knox AI platform. Right now, they can get that information, and not just CVEs, like Irina hit on, is give the CVEs, but also context around it. What is the risk to that thing? What else is configured around that to help, again, speed that remediation? How can we take action more quickly to reduce risk and meet these compliance frameworks at the same time? Right? That's really the key to Wiz, is help accelerate that speed with more information more quickly with that context attached.
Fantastic. Thank you, guys. That was super cool. I'm going to eat in a little bit of our end Q&A time. Instead, we're going to put it here. So I'm going to do another maybe 4 minutes of Q&A here. So 1:35, then we'll hand it over to Adam. From the audience, Knox, if you are using an underlying LLM provider, is it FedRAMP authorized? If not, are you hosting your own LLM? What's up with the LLM situation?
Yeah, good question. So yes, we are. You know, without getting to the specifics on how it is that we do it, it is authorized, and it's authorized for the impact levels that we use it for.
There you go. Another question here is, how do you handle infrastructure as code drift? Did you compare the IAC findings to actual state running in the system?
Oh, great question. Well, yeah, and if you look back at the, you know, once you guys have a copy of the slide, if you look at how it is we ingest things, again, you'll notice 4 points of ingestion. One is infrastructure as code, and another one is the actual state itself from the hyperscaler. So we are indeed crawling what the infrastructure is as it is in its current state, and then there is a comparison between the two to understand if there is drift. ClickOps is a bad thing. GitOps is the only way to go. And everybody should be living that Git life.
Wise words there. This one's probably more for John over here on the Coalfire side. How much time did it take you to do the validation here? And did you consume the JSON output programmatically, or was that just an artifact that was kind of on the side?
So we actually, so as far as time, like I said, the attestation letter was about an hour worth of effort. Now we spent quite a few hours. I just, if I had to guess, 25 to 30 hours validating the schema, validating the mappings between KSIs and NIST controls, and then also reviewing evidence. So, a typical FedRAMP assessment, you're not going to complete within 1 week and by one person even. And so that's the key that I looked at. And as far as programmatically, we actually had the raw JSON output, and we actually consumed that ourselves to make sure that nothing was changed, nothing was modified, and make sure that we had that correct schema and the correct information.
Super good stuff. All right, there's one more question in the queue here, but it's for the PMO, and we're going to focus on you all today. So we're going to go ahead and thank you for that demonstration. Stick around, because if we still have a little bit of time at the end, we might bring you back for questions. But otherwise, Adam, over to you, sir.
How's my audio? Because if I have to go full gaming headset, I will. Okay.
It seems okay.
Okay. All right. I'll just go ahead and jump right into it. Like I said, our story, our submission is, I feel like an ant in the world of this GRC tower of enterprise compliance. So I'm gonna jump right into it here.
All right, hold on, Adam. Sorry, I lied. I think you might need to go full gaming headset on us. It
Okay.
got real crackly.
So I don't. Of course it would happen. Give me 1 second. I'm sorry.
Yeah, no worries. I'll jump back to Knox for a second while you do that, because there's a question that came in, which is a little bit confusing. So I'm just gonna read it and see if it makes sense after I say it out loud. If Knox and the like will be running within the CSP's environment on the management side, why would it need to be FedRAMPed? Where would the use case of an agency leverage Knox? Actually, is a good question. How would the federal government use your service?
Yeah, sure. So I can take that. So essentially what we do is as per the KSI's dictate, we have machine readable outputs. We also have a human readable version of this. We use it specifically in our ConMon today. So as we meet with our agencies, either on a one-on-one basis or in a collaborative means, we essentially go through what's open, why it is that we're off from the mark, what it means to actually be on the mark, and then we can have real productive conversations because the answers are very much clear and transparent. Moreover, should there be a case where a KSI need to have both some type of evidence as proof, whether it be presence of a service along with documentation, and there's still curiosity about how it is that meets or falls short, it lends itself to a real conversation. And that's what we're able to drive with our agencies. And the output of that, manifestation of that, is it essentially builds confidence within the system that they're acquiring.
Yeah, I think I'll also just add to that in general, if you have a GRC automation platform that is attesting to the security of something, we want that thing to be FedRAMPed. All right, Adam, let's try your gaming headset, see how it works. Now we got no audio.
Okay, is this better?
Yeah, all right, let's do it. We're gonna do it like this.
All right. Sorry about the mix up here. Okay, we're just gonna jump right into it. So, as I mentioned before, our whole premise around 20X was just like, let's build something. Pete and company gave a blank, essentially a blank template to what was required, right? It's just like, hey, here are the requirements, go build something. And so I wanted to build something that was essentially meeting the requirements, but was also pragmatic for our team, right? And by our team, I really just mean like one person, right? This was just really built by myself with the help of my DevOps engineer on the infrastructure side and application configuration and things like that. So Can everyone see this? Just want to make sure.
You're good.
Okay, perfect. So the real goal was like take the controls, take the KSI requirements, and Ethan can speak to this. He was part of the initial piece, and the original pilot was, hey, I guess in my mind it was like, hey, go build something, and it can kind of be manual, and can be some automation. So we had like manual. The first GitHub repo, I was just like, all right, I'm gonna go do a Git repo. It's the easiest thing to do. I didn't have to procure anything. I didn't have to go to my boss and say I need to buy something to do the pilot. I just did what was easiest and most cost effective. And the original repo was like a mix of manual evidence, like uploads of PDFs, like, hey, here's CSVO2, here's how we're meeting it, and there were screen grabs, right? I was doing a very traditional like Rev 4, Rev-minded thing, and in my mind, I was like, no, we're doing something cool. We kind of have automation because we're running a GitHub action to check if that's present. So like, oh, that works, right? I was like, no. So Ethan, we worked close together. And he was just like, hey, man, are you going to automate it or are you going to go manual? Like, kind of, what are you going to do? And I was like, oh, yeah, you're right. So I nuked the first repo. And then when you came out with the next directives, we went ahead and just went full force with a whole new repo with automation in mind only. So that's where essentially we have, this is the pretty front end of it, but the back end is very much the two repos, public and private. So we have a private repo and we run GitHub actions to essentially run a job every 24 hours. And in that job, we do a ton of things. First we use a OpenID Connect role assumption to assume a role into AWS, and it's a read-only role. Again, thanks to Ethan, pointed out some security issues early on because we were using GitHub secrets, which isn't terrible, but obviously you don't want to keep them in there very long, and it's just kind of a security risk to have them sitting in Git, and Git has had issues every so often. So we switched to an OpenID Connect role, and so now it's totally safe and secure, no secrets there, and it just assumes that role and it reads. That role has permissions to read through the accounts so that we can pull the correct data through our CLI. So we created what's called a CLI command register, and we just kind of use that as our source of truth. So I'll kind of walk through things as we talk about it. So what you see here is live. This is legitimately live data. This is what we used for our attestation for our initial assessment from Fortreum. This is all live. It just ran last night when I was awake way too late, just doing things. I ran it manually, but it will run 24 hours after last manual run. It just 24 hours after that. We have a cool night mode because I've blinded myself by by the light of computers and laptops over the years, and so I needed a night mode for myself. But it does tell you sort of last updated, and in our trust center area, we kind of put in sort of a quasi marketplace description. This is basically just a description of the service. We do have a listing if you wanted to see that, a link to the repo, and you can actually download essentially the JSON, the source of truth that runs a ton of the data here. You can literally download it, just look at it if you want. We can show that in a little bit, but just kind of going through. We also have a failed report, but nothing's failing. So if something were to fail, you can download that as a markdown and just use that as a reference. But kind of going into the meat and potatoes of what we have here. Essentially what we did was we curated a list of commands for each KSI, with the exception of like some of the more manual ones like row specific training. The command is just to look for the manual evidence in that particular directory in the private repo. But as you get more into the nitty gritty of technical commands, so we could just do like change management, right? So these are all the verbatim KSI wording for the requirement based on the official KSI release. So we put that in there just so we can keep everything consistent. And then we have some cool things you can jump into. So since like CLI commands are our source of truth for how we curate a pass or fail, you can actually go in here and you can look at the commands, how many success rate. So one failed. You can see which one actually failed. We can see that in a second, but you also get a justification for why it passed. And we'll get into what that logic is. It's really just Python, and it's really just Python functions that are doing a ton of if, else, if, else kind of thing. But as you jump in here, here's the actual commands that we're using, that we're able to take the output of those and parse them and make sense of them for the evidence, essentially the evidence generator to give us information about it. So once you see, we can come down, it failed. I think this one's been failing since day one, and I was trying to do something, and it ended up being obsolete or not relevant to us in a way. So that's just lingering, but it'll show that it failed. So that's for the technical piece, like if you want to see what we're doing on the command side. And then we have something called improvement, like why it improves. So we put in this model as part of being early in the pilot. There was like these phases that I thought we were going to do, but it happened so fast that the phases just withered away pretty quickly. So the original thought was like, okay, pilot was basic configuration. If you have basic encryption, or you have, basic, enterprise, not enterprise, but basic logging and monitoring. That was pilot phase. Like, oh, okay, that's good. And then we phased it to where there's basic, there's, sort of moderate, there's enterprise, and then there's just like you're a rock star in your configuration. So we left that logic in as we kept building to say, hey, not only are we continuously monitoring and continuously attesting to the security posture, we're also doing what we call continuous improvement, where it says we can be better. Like for example, 82%. I mean, that's good, but it's like you could do better. Very Kobe Bryant, job's not done, you can do better kind of thing. So we kept that in there just as the full transparency. I fell in love with transparency. I fell in love with the public, transparent aspect of security. And so I probably went too crazy. I really ran away with that a little bit. And we'll get into a little bit of that as we continue. But that will tell you why there's improvement. And this will kind of open a GitHub issue in our public repo if you wanted to say, hey, you know what? I don't like that. This, or tell me more about that. Why, and it'll just pre-populate with sort of, we probably should clean that up a little bit, but it just will pre-populate into a GitHub issue. For things that passed, with passing, 100% passing, essentially, again, commands will tell you why that passed, and then look, we have another why pass. So we have a threshold that we've set, and this was attested to by Fortreum, for why something passed. We had to, we use Terraform, and we don't really use code build and AWS native for sort of our change management. So we had to finagle our logic that was trying to be cloud native with, we had to get a little bit fancy or kind of put things together that we weren't expecting. So there's things that the way the rules function is that if you meet the threshold, then you would pass, but you still have that opportunity for improvement. And you can actually see, why something passed. For example, for security validation for CNA01, for inbound and outbound traffic, it's going to tell you, traffic controls are comprehensive, strong egress, strong ingress. And then a funny story around this one, and this goes back to a story that I think it was Sunstone, who had a moderate, or they had a high authorization or a high service, and they found a problem while doing a low in their configuration in their high. During this, specifically this one, I remember I told the team about, okay, these are kind of the ingress egress rules we need to configure. They said they did it, and then I ran the rule, and then we were failing, and I thought it was just a program, I thought it was just a code thing. Come to find out, it was failing because it should, because there was some misconfiguration on the ingress egress, some miscommunication of like, hey, I thought you said. I was like, oh, no, no, no. So then we fixed it, and then we were able to get this. So in real time, we were like working through our logic, the KSI requirements, and it was really cool to kind of do that. So that's that piece. I mean, we do have another improvement opportunities. This one will just kind of tell you. This one will kind of just tell you like, hey, there's room for improvement. You can, you only have 1 out of 4 Lambda isolation, but we only use 1, so it's just kind of putting a bar higher than I think we thought. So that transparency we wanted to just keep as we work through the pilot and things like that. So that's the main piece of sort of the KSIs. So you can actually break down, how you want to look at them there. Another cool thing as part of that is for the API piece, we have this trust center piece where you can actually go in and get the JSON, like call the markdown, you can call the evidence commit metadata to look at the SHAs if you wanted the hash. You can do that. And so you can do something like, I think it's this. Yeah, so we just use like an online. I didn't want to use like Postman or anything. I didn't want to, too lazy to download it. So you can go and just call it because it's just publicly out there on the internet, and you can just go and here's what our KSI validations look like that are our source of truth, right? It tells you why it passed, assertion, this is what was attested to by Fortreum. Ton of information there about the commands that are executed, why it passed, when it passed, that whole thing, where it is. So that's just really the source of truth for our validations and how we make that publicly available to anyone, any agency or even a prospective agency that maybe wants to do business, but they don't want to go through the gates of marketing and white paper signups and stuff. So that's how I read the vision of 20X, was from a true boots on the ground perspective. And as you see there, live data loaded, it'll just refresh every like 5 minutes. Sometimes we run into errors and it'll tell you that there's no data to load. And then, that will let us troubleshoot. But one thing I'll touch on just really quickly, but it's really kind of prototypey right now because I did it over the weekend, last week, kind of working through the night, I was trying to incorporate the significant change notifications into the Trust Center by using automation. What we really did was kind of interesting. We created a few scripts and created some a JSON sort of skeleton so that we could meet some of the significant change notification requirements. So for like identifying the necessary parties, for just general management, and then for like the decision tree aspect, we're like, oh, we probably can automate that. So we have something here where we're being transparent around like our change, and we identify if the change is essentially routine or adaptive or transformative, and we do that in the logic of the script that says, hey, if this Terraform state file for, I don't know, firewalls or load balancers, if that changes, and we do like a diff, comparison, if that changes, that automatically gets flagged as, an adaptive or transformative based on some of the other logic. So far, we haven't, we did that a week ago, and we had shown an adaptive change occurring, but now it's capturing our evidence pipeline. So it's just going to keep capturing the routine occurring. And you can kind of see like in the files, it's capturing those files. You can do the same. You can go with the API and just go look at what it is. You can go look at the JSON. So we kind of have it to where we are meeting those requirements for change notification. The 3PAL, kind of the type, right? And then we just kind of point out what the files were. And then we kind of give a breakdown of those files. So we're still working through it. I thought it was just a cool thing to try to start doing, and we actually are capturing, I think, 100% of the change management notification requirements doing it. So I think it's pretty cool. I saw my engineer, they changed the README file in one of the repos for our infrastructure, and it didn't flag it because it has sort of like a grep to go over READMEs and markdowns that are considered not, you know, significant enough to flag them. So that logic worked. So I was pretty happy with that. So that's kind of honestly, that's kind of the trust center in a nutshell. Our POAM piece, as we work through what that looks like in 20x. Right now, we just have it as failed KSIs, and our KSIs will fail even if the command fails. So if AWS decides to change the syntax and change a flag on something or slightly do anything different than what our command register has, it'll fail. And so we have that as well, and then we have just like the low risk 90-day, and then kind of like here's how you can be better sort of thing. And we're kind of working with the team to figure out what that looks like as FedRAMP 20x moves forward. So we can I just want to take you quickly sort of into the private repo. I won't divulge anything private per se here. I just wanted to kind of give a glimpse of what it looks like, particularly the GitHub action, because I think it's pretty cool, but you have to excuse the yeah, there's a ton of stuff. So it takes 5 minutes to run, which means I'm not a developer, and I obviously I probably could optimize code or something. It takes a little bit to run, but when it does run, it runs 3 different jobs, and this is kind of the debugging for all of the jobs it does. I won't pop into too much of this because it's not messy. It's actually well organized, but it's just, there's a lot going on in here. But you can get an idea of what we're doing from that perspective, where we're running the command registers, the source of truth, and it's running that multi-command CLI per KSI, and then it's just taking those results as output and then running them through a validation engine, which is just Python that looks at and parses the output. And we have like a cool tool that kind of helped us through this that we ended up using. I'll just pull it up here. It kind of helps you to understand the evidence. Like, so you can, for example, I chose option 3, show assessment summary. So it'll kind of tell you how we assess. So we do evidence collection. Our scoring patterns are foundation-based, enhancement-based, and we have penalty logic. What that looks like a passing control, like what that actually looks like. And that's kind of how we break it down. And then there's also, we also take it a little bit further. I believe it's yeah. So we have something called a command validation reference guide. It kind of tells you how we curated those CLI commands, since we're putting all of our eggs in like a CLI command bucket or basket rather. We wanted to make sure that there was super transparency around why we chose these particular commands and what the technical validation is around them. So for example, if we just look at like CNA2, we're covering segmentation, microsegmentation, network isolation, things like that. And that's how we feel comfortable attesting to those CLIs. So there's a ton of stuff in our public and our private. I mean, our public group has a ton of stuff. We make everything short of the actual raw output available. Everything's available short of the raw output and the rules. And the only reason we didn't put the rules is just it's a very long file, and we just didn't want to give people iSource, so we just kind of put that in there. We do have the command register. If anyone was wanting to look at how we actually do it, it literally just pulls this as part of that GitHub action, and yeah, and then runs the logic based on the output. So we actually, I think I can kind of show you. Yeah, so yeah, that's where the evidence. And yeah, so I mean, we're showing things in a public and transparent way, and I think that's partly where we wanted to go with this submission. And obviously, we're still tweaking things and working on things as we go. And I hope that it was helpful to anyone who found it helpful. And we would love feedback. And thank you. That's all I really have.
Yeah, legendary, man. There weren't a lot of questions that came in, but there were a lot of really positive comments and feedback. I want to read this one for you, which was like, love it. You rock doing this all on your own. I want to be on your team. So lots of appreciation from folks. Thank you both for your participation. Thank you for doing this. Thank you for being a part of making FedRAMP better, making this experience better for everyone. I love like the kind of two perspectives of a super deep, experienced, engine that has been working with FedRAMP for years and years and years, adopting this new thing next to it. A few guys in a garage just deciding like, let's go. I mean, I think at one point, Ethan might have been the first person that publicly in the working groups was posting some theoretical code for how to check S3 bucket encryption. And it was like pretty sick. I'm like, is this going to happen? So I love it. I appreciate you guys. There's links to both of this stuff. They're going to be in the chat, and they're also going to be in the YouTube comments. If you want to look through these public submissions later, please do get a feel for things. There's a thread in the community working groups that has their contact, has some general information about these folks. You want to reach out, learn more. As I close this out, I just want to remind folks that if you check out the discussion thread in the community working groups about the continuous vulnerability management special event, we're going to have another big industry event next week with looks like around 8 to 10 cloud service providers. We'll be talking about how they do vulnerability management and how that overlaps with our new draft standard. And then we're going to be talking about that in the Rev 5 community working group on the 6th of August as well to dig in more so everyone has a chance to see where we're going with all of this. With that, we're going to close things out. Thank you so much. See you all on the other side. Cheers.